In this video we're going to look at a formula that is handy for getting the area of a triangle for any triangle where all you need to know is some side lengths and an angle. So you're probably quite familiar with the formula at the top here that has half base times height, right? What we've been using so far. Now, what we can do to get ourselves a bit of a better one, save us having to work out what this height is all the time, is we can just express the height in terms of some trig. So if you realize that we've got here right angle triangles, one there, one there. Well, if you think about this A here, well, sine of A is opposite over hypotenuse, so it's h over c. So rearranging for h, we get c sine of A. Yeah. So in terms of this formula, well, half base times height. The base is just this letter b conveniently. So we replace this h, the height, with c sine of A. We get this formula for the area of the triangle ABC, half b times c times sine of A. Now, you might realize what this is saying is if you do half times the two side lengths and the sine of the angle in between, you're going to get the area of this triangle, as we can just see from that proof. So, pretty handy formula. All you need is two side lengths and the angle between them, and you can get the area of any triangle. Let's see how that works. Here we've got a triangle where we've got, conveniently, side length, angle between them. Great. We can just use our formula. That area is half times the two side lengths, so 5.2 times 7.1 times sine of the angle between them, 42 degrees. So what we can do is just chuck that in a calculator because we don't have any exact values here. So we've got 0.5 for half times 5.2 times 7.1 times sine of 42 degrees. I'm going to need my degree symbol again because I'm not in degrees mode. Perhaps I should just put it in degrees mode. Anyway, we get, let's just write that down before we move on. The area must be 12.35, thereabouts. And what are we working? We're working in centimeters. So if these were in centimeters and this is an area, this must be centimeters squared. And there we have it. There is the answer to that first example. So let's move on and just have a look at another one. So here we have a side length, we have two angles, but we're missing the other side length. So if we want to get the area of this using that formula, we're going to need another side length. It doesn't really matter which one we get, especially because it's pretty easy to just straight away get this other angle, right? Because we know it's got to add up to 180. So we need 60 plus this plus that equals 180. If I put 40 here, well, 40 plus 60, that's 100, plus 80, 180. So this must be 40 degrees, right? Now, we need a side length. We've got all these angles. We've got a side length. How about using the sine rule, right? Let's just label this. I'm going to use maybe ABC. Easy to avoid making mistakes writing them. So I think, so what this is B, this is C, this is little a. So why don't we get we'll get B and we'll get A. So we'll get little a, right? So little a on sine of A, so sine of 80, is equal to little b, 7, on sine of 60. And then what we can do is rearrange for A and use our calculator. So it's what? Sine of 80 degrees times 7 sine of 60. Let's just get out our calculator and work out what that is. So we get sine of 80. What I'm going to do actually is, let's just, enough of this messing around in radians, we're going to stick to degrees. So sine of 80 times by our little 7 on sine 60. And I'm going to put in a decimal point, so it gives me decimals. We get that is, what, 7.96? 7.96. Let's see if we need any units there. We just go back to our example. No units, so we can just keep it at 7.96. Okay, this is good. So that was A, was it? So This is 7.96. Now we have a side length, the angle between them, so we can use our area formula. It's just half times the product of our side length, so 7 times 7.96 times sine of the angle between, so sine of 40. So let's go back here, and we've got 0.5 times 7 times, just make sure we're actually putting things in, times 7 times, I'm just going to go up here and grab this, times sine of 40, and we get 17.96 units squared. So let's write that up here while we can, 17.91 units squared for our area. And let's have a look, same thing as I got the last time I did this. Very good.